Have you ever thought about it? At 7:30 a.m., could the hand on your clock perhaps be a lie that is billions of years old? Is the true time hidden in the invisible vibrations of atoms? Do you know what time really is? And perhaps those atoms are searching for dark matter right now. The thing we call time might be the universe's greatest illusion. We have all surrendered to and accepted the word time. But only very few of us who reflect have truly asked, what is time? Today, I'm going to show you the true face of time. Quantum clocks, this is not just a technical innovation. This is a revolution where consciousness and matter intersect. A breakthrough that even Einstein couldn't have dreamed of. And these quantum clocks show that you are at the center of this innovative revolution and don't even know it. If you want to understand time not just as a measure, but as a frequency, watch this until the end. What I'm telling you will permanently change your perception of reality and make you understand whether time even exists. Quantum crystals, self-running clocks in the quantum world. A study was conducted on quantum clocks and time. It opens doors to the physics of multi-particle quantum systems and new quantum technologies. And this was called time crystals. Scientists have developed a new quantum clock that can measure time without needing classical counters. This technology, which operates without known clockwork mechanisms and cyclical movements, offers a completely new approach to time measurement. An international team of physicists developed the system based on wave packets formed from high-energy states of helium atoms. These wave packets, when interacting with light, generate unique patterns during their lifetime called quantum fingerprints. Researchers analyzed these patterns and were able to measure time at the femtosecond level, a quadrillionth of a second. The new method does not count oscillations or recurring cycles like classical clocks. Instead, it relies on the moment the wave packet was created to record absolute time. This confirms that the measured time is completely freed from systematic errors. Calculations matched. The experiments were performed by exciting atoms with ultra-short laser pulses to create photoelectric effects. The data obtained corresponded exactly to the theoretical calculations. According to experts, even an observation of just a few nanoseconds is enough to correctly measure time. Furthermore, these quantum wave packets can store time information for several dozens or even hundreds of nanoseconds. And this time reorders many things we understand about minutes, hours, and familiar time.
The world's best clocks might soon answer this question. Observing how time might be retrograde or variable in the quantum realm allows us to explore previously uncharted physics and quantum fields. The idea that the flow of time could change or expand comes from Einstein's special theory of relativity. The closer an object gets to the speed of light, the slower time passes for a stationary observer. Einstein expanded this through general relativity. A gravitational field could have a shocking effect on time. Igor Pekovsky from the Stevens Institute of Technology and his team are using ultra-precise ion clocks to investigate whether something like time even exists in the microscopic quantum world. Pekovsky says, previous experiments have always perceived classical time, a time that has nothing to do with quantum mechanics. But with ion clocks, we found that this explanation fails in a certain regime. According to Pekovsky, the ion clock, determined by the laws of quantum mechanics, offers a perfect environment to observe classical and relativistic effects. The researchers also mathematically modeled how the superposition states of the ions affect the clock's signal. The clock's time stamping is directly linked to the quantum entanglement of ions and electrons. Christian Sonner from Colorado State University says, normally, you have to use tricks in experiments to create loops. Here, it is fascinating that you can see the effect even if you don't intend to. These clocks consist of thousands of ions cooled to near absolute zero, and their quantum states and electrons can be controlled with extreme precision by electromagnetic forces. The clock's function is determined by electrons. According to Gabriel Sorchi, the next step will be to add gravity to study the quantum nature of the clock together with the gravitational effect. David Hume from the National Institute of Standards and Technology in Colorado says, "I think this is quite feasible with current technology. The biggest challenge is eliminating small disturbances from the experimental environment. Such experiments will investigate the interactions between quantum theory and special relativity, expanding the boundaries of contemporary physics and uncovering previously unexplored physical and quantum phenomena. The first moment when time lied question, what is time and can you really measure it? Most of us think time is an unstoppable flow, measured by the hands of a clock. But quantum physics tells us something else. Time is a vibration, a frequency, and whoever controls this frequency also shapes reality." First, back to the year 1967. Scientists from all over the world gathered to define the second. What did they do? They chose an atom, cesium-133. This atom oscillates exactly 9,192,631,770 times per second. Scientists said, "Okay, folks, this number of oscillations is now 1 second. So the definition of time is not a law of nature, but an agreement between some people. What if we could measure it even more precisely?" That is exactly why quantum clocks are breaking the old order. They no longer measure time with microwaves, but with light frequencies. The result? A quantum clock would have a deviation of only 1 second even after 13.8 billion years. Religious perspectives on time. Islam, fate and God's will. God's constant intervention in the universe ensures that events happen in an orderly manner, similar to quantum uncertainties. The sun and planets move in fixed orbits. Surah Yasin, verse 40, "Neither can the sun overtake the moon, nor can the night outstrip the day. Each in an orbit is swimming." Islamic thinkers emphasize that natural laws are a reflection of divine order, which corresponds with modern physics and quantum fields. Christianity, God's creation and universal order. Christian thinkers could see quantum uncertainties as a scientific metaphor for God's influence on the world. John Polkinghorne, physicist and theologian, argues that quantum mechanics offers a scientific metaphor for God's influence. Judaism, speculative thoughts about the nature of the universe. The possibility that every event has multiple possibilities can show parallels to quantum mechanics. Some Jewish thinkers interpret quantum mechanics as an invisible but effective dimension of God's creative plan. Buddhism, meaning and consciousness. In Buddhist teachings, reality is directly linked to the mind's perception. Everything constantly changes and every moment is newly created, which aligns with quantum mechanics regarding probability and superposition. Mental observation and matter. Just as observation influences the behavior of particles in quantum physics, consciousness and meditation shape the experienced reality. The Dalai Lama emphasizes that modern physics and quantum mechanics can align with Buddhist philosophy and are open to exploring the relationship between consciousness and matter. Small exercise. Close your eyes for 10 seconds and feel the time, then write in the comments what you felt. We'll compare it at the end of the video.
The heart of quantum clocks is ultra-cold atoms. The biggest problem that disturbs accuracy is the thermal motion of the atoms. Moving atoms disturb the signal. Scientists use strong lasers to cool the atoms to nearly absolute zero, millionths of a Kelvin, and place them in small grid cages, optical lattices. This allows thousands of atoms to be studied in isolation simultaneously. My hero here, strontium-8 atom. Optical frequencies oscillate so quickly that they cannot be counted electronically. Imagine 430 trillion oscillations per second. This is where frequency combs come in. They convert the extremely high optical frequencies into lower, electronically measurable microwave frequencies, like a gear mechanism. Without these combs, quantum clocks would just be laboratory experiments. With them, clocks can be so precise that they theoretically don't deviate by even 1 second over a very long time.
The precision of these clocks is so great that we can now measure the effects of Einstein's general relativity in everyday life. The stronger the gravity, the slower time passes. With quantum clocks, we can detect differences in the flow of time, even at height differences of just a few millimeters. Two clocks at different heights show that the lower one actually runs slightly slower.
Why change the definition of the second? The current cesium definition dates back to the 1960s, but there is something better: optical quantum clocks like the one with strontium. International authorities, BIPM, plan to couple the second to an atom in the 2030s to make time more stable and universal. This revision is not just a technical detail, but a victory of quantum metrology, and will make everything from smartphones to global networks more precise.
How will quantum clocks change our lives? Ultra-precise GPS. GPS is based on signal travel times. An error of just 0.3 nanoseconds leads to a 10-centimeter deviation. With quantum clocks, localization can be accurate to the millimeter, crucial for autonomous vehicles and drones. Quantum entanglement. Atoms can be entangled to eliminate measurement errors between clocks. This theoretically brings the precision closer to the Heisenberg limit. Future quantum computers need this ultra-precise time infrastructure.
Can quantum clocks solve the secrets of the universe? Perhaps the coolest part, quantum clocks become detectives that don't just measure time, but decipher the secrets of the universe. Dark matter makes up the majority of the universe. Theories suggest that these mysterious particles minimally affect the fundamental constants of atoms. By constantly comparing several quantum clocks made of different atoms, these small frequency changes can be recorded as the Earth moves through the dark matter halo. So quantum clocks don't just measure time, they listen to the silent rhythm of the universe. Now it is up to us to observe. If what you have heard here has resonated with you, then I invite you, by subscribing, you consciously send the message to the universe: I am ready to receive. Pause briefly. Write only one word in the comments: ready. Write it with feeling, because in that moment, you move from receiving energy to giving energy, and the universe responds on that frequency.